Hey everybody, Mrs. Bixler here, and we are on day 2 of RTD problems, which is so exciting. So let's just do a quick recap. Remember, there are 3 types of RTD problems: catch up, work done or opposite direction, and same direction. You always set up your RTD chart first, and then you find the distances for each person involved in the problem. So I want you to pause the video here and I want you to think about what you do for each type of problem, what you do with the distances. Pause your video and I'll see you in a second. Okay, we're back. So a catch-up problem. Remember, in a catch-up problem, you will literally see the words catch up, typically, and you set up your RTD chart, and then with your distances, you set them equal. Woo-woo! For a work done or an opposite direction problem, remember, in these types of problems, there are either people who are working together to get things done, like making hats or making cupcakes or whatever, or the people are physically moving in opposite directions. And usually there's like a set number at the end, like a set distance or a set number of hats that they've made or whatever. And in a work done or an opposite direction problem, you add your distances. Whoop, whoop. And then the last one for a same direction problem. So a same direction problem is when the people are moving in the same direction. So in a catch-up problem, they're moving in the same direction too, but remember, one person's catching the other one. In a same direction problem, what we're interested in is when the distance between them is a certain amount. So you'll also have a set distance in a same direction problem, which you won't in a catch-up problem. But in a same direction problem, you are going to subtract your distances. So how did you do? 3 for 3? Woo-hoo! All right, so let's do a couple more practice problems, and then I will let you guys go and tackle the next worksheet. All right, so problem number 1, go ahead and read it, and I want you to pause your video, and I want you to first write down what type of problem it is, and then what you do with your distances, and then come back and press play. All right, so we're back. So this is a type of problem where we've got people going in the same direction, and we're interested in when there's a certain distance between them. So this is a same direction problem. And remember, in the same direction problem, you subtract your distances. Okay, pause the video again. I want you to make your RTD chart, and I want you to set up your equation to solve. Go for it. Okay, we're back. So remember, this is a same direction problem, and you are going to be subtracting your distances. So let's grab this, and I want to see your chart. So we've got me, Mrs. Bixler, and here's my rate, my time, and then my distance, because rate times time equals distance. Remember, rate times time equals distance. And then you've got my mom's rate. And her time, remember, she's 1 hour after me. And then, so her distance is 150 times t minus 1. And then I just went ahead and distributed it. And then the equation that you're going to set up looks like this. So here is my mom's distance. Remember, for same direction, you're going to be subtracting the distances. So my mom's distance is 150t minus 150. And mine is that 100t. So 150t minus 150, and then mine is that 100t. So you're going to subtract them and then set them equal to 200. And then here's what you should have. 150t minus 150, and then so t equals 7 hours. So after 7 hours, after I've been traveling for 7 hours, my mom's been traveling for 6 hours, we are then going to be 200 miles apart. All right, so hopefully you felt good about that one. Let's move on to the next. All right, same sort of thing. I want you to read this, pause the video, and just write down what type of problem this is and what you do with the distances. And then we'll come back together. All right, so we're back. So my brother and I live 120 miles apart, and I go in this direction and he goes in this direction. We are traveling in opposite directions. So this is an opposite direction problem. Excuse my pen delay. And in an opposite direction problem, remember, you are going to add the distances together. So this is like opposite direction or work done. So you're going to add your distances together. Now I want you to pause the video again. I want you to set up the RTD chart and then set up your equation. Go for it. All right, we're back. So hopefully your RTD chart looks like this. So I have mine and my brother's, our rate, and our distances. I'm going to add my distances together. And then I wind up getting that 40x equals, 120. And then 120 divided by 40 is 3. So if we leave at 1 p.m., how long does it take? Well, 1 p.m. plus 3 hours is going to be 4 p.m. And you're done. All right, here we go. Last problem of the day. Same thing, read the problem, pause the video, read the problem, and then fill in what type of this is and what you're going to do with the distances. Go for it. Okay, we're back. So Darby and Larby, they're leaving the bus stop and they leave at the same time, but Darby's walking faster than Larby. And I want to know at what point, what time are they 2.5 miles apart? So they're walking in the same direction. And so this is going to be a same direction problem. And remember, same direction, you subtract your distances. Pause the video, make your RTD chart, and make your equation, and then we'll come back. Okay, we're back together. Is this what your RTD chart looked like? Pretty straightforward, right? Because they're leaving at the same time. So there's no like x minus 1 or t minus 1 for the time. And then all we've got here is we've got 5x minus 3x equals 2.5. And remember, this you have to do 5x first because that's the faster person, right? So here's here's Darby's distance, and then you're going to subtract Larby's distance. So then I get 2x equals 2.5. Again, sorry for the delay in my pen. So 2x equals 2.5. 2.5 divided by 2 to solve for x is going to be 1.25. So if x equals 1.25, that's an hour and a quarter. That's going to be at 7:15 because it's an hour and a quarter after 6 p.m. Cool. Hope that makes sense. Go ahead and try the next worksheet, and we will see each other soon. Thanks.